Hello, and welcome to CicadaCast, Episode 2. Recorded live in the CicadaSolvers Discord, today's topics are TOR, the deep web hash, and Onion v2 deprecation. My name is Artorius. I moderate the CicadaSolvers Discord, and I am also the creator of CicadaSolvers.com, which is the website where this podcast's RSS feed is located. We'll be discussing CicadaSolvers.com a bit more in depth on the next episode. But for now, allow me to introduce our two other hosts for this evening. First, we have CicadaSolvers Discord server administrator Taiwo.
Hi, I'm Taiwo. You probably remember me from last time. I probably don't sound the same because I have a sore throat. Sorry about that. I've been managing the CicadaSolvers community since around 2013. And I'm joined again with Puck.
Hi everybody, I'm Puck. I've been the community organizer since the start of 2020, and today we're also joined by our guest speaker, Twex.
I go by the name Twex. I joined the community a little over 9 months ago, around last Christmas. I've been mainly interested in investigating the deep web hash, but also CicadaOS and other various parts of the puzzle.
Without further ado, let's dive into the topics at hand. Puck, would you like to give our listeners some background context on what exactly we mean when we say the deep web hash?
Sure. So basically the current step of the Cicada puzzles is Liber Primus, and out of the current step of that, page 56.jpg, was decoded to say an end. Within the deep web, there exists a page that hashes 2, and they give us a 128 character hexadecimal hash. And they say, it is the duty of every pilgrim to seek out this page. Basically, a hash is a non-reversible transformation to validate that two parties have the same source material without necessarily having to share the source material itself with the other person. Basically, the phrase deep web, which is another part of this, is often misunderstood. While the phrase deep web refers to any page not accessible by search engines, it can also reference services on anonymized networks such as TOR. And for more on that, I'll hand it over to Taiwo.
Thanks, Puck. So yeah, to start off, to give a little context for this episode, I want to talk a little bit about what TOR is and how exactly it's relevant to the Cicada 3301 puzzles. The first thing I want to say about TOR is to clarify a couple of misconceptions. Some of the things you may have heard about the TOR network is its associations with things like the sale of illicit substances, basically breaking the law in general, hackers, illegal files, database leaks, and things of that nature. None of these things have any intrinsic link to the network itself or the message that the objective of the project as a whole. The TOR network is simply an anonymizing network that allows computers to communicate with each other anonymously. It does this. Any one user may access any ClearNet service that you know and love, like like YouTube or something, through by utilizing this anonymized network of nodes. So effectively, a little bit about the way that it works is that when you send a packet through the TOR network, it goes onto the network and it gets passed around a bunch of different nodes. And it's encrypted in such a way in layers like an onion, so that each node unwraps one layer of encryption and passes it on to the next, such that no node on the network knows which node actually initiated the request. And using this method, basically, it's impossible to tell who exactly initiated the connection. Now, on this network also are things called hidden services. We'll be talking about those today as well. So hidden services are services that are hosted on the network itself that allow people to create services on the network that are accessed internally. So without actually exiting the network ever, it's possible to both request content from these services and host the services themselves whilst remaining completely anonymous. This has been used by Cicada pretty much every single year since 2012, on every single puzzle since 2012, and also probably used by them to access various ClearNet services that they've used, such as Twitter and Reddit. Onion or hidden services use onion URLs, which are fairly similar to regular URLs that you will use today, except for they use the TLD .onion in place of where there would usually be a .com or .org. And the contents of the domain name is a randomly generated alphanumeric string. The version 2 onion URLs use a 16-character alphanumeric string, whereas the version 3 onion URLs use a 56-character string. For a couple of new developments on that, I'd like to hand you over to Twix.
When the Liber Primus was created, so back in 2014, basically only v2 onion addresses were in existence. However, as of mid-October, the v3 onion protocol was basically replaced the v2 onion addresses, and as a result of this, v2 addresses are now deprecated. This is quite interesting for the community because, well, if we assume that Cicada 3301 created basically, well, hosted the deep web hash on a v2 onion address, well, this means that in a couple of months, when the v2 onion layer will really be deprecated, we won't be able to access the page anymore, and so it introduced new problematics, and basically we don't currently know the full extent of the consequences of this deprecation, and lately this has been quite a burning issue in the community.
Thank you for that explanation, Twix. Now that we've laid some of the basic groundwork for understanding the topics that we'll be discussing in this episode, let's jump into the theory. Taiwo, brute forcing is one of the most commonly brought up topics by newcomers when we're discussing the deep web hash. Is it feasible?
Well, yes and no. When the hash was released initially, or at least when we discovered the deep web hash, people immediately jumped to brute forcing. People were hashing pretty much everything they could get their hands on. People were scraping onion directories. People were, brute forcing all kinds of pages on Showdown and other kinds of networks. The underlying nature of a deep web hash, however, is that because the page itself is supposed to be unindexed, these methods weren't really very fruitful in that aspect. However, there was one attempt that was fairly interesting with regards to the TOR network, which was that it actually gained quite a lot of media attention. A couple of users that I will not name basically discovered a brand new exploit, or at least utilized a brand new exploit in the TOR network that allowed us, or them, should I say, to using around 100 servers, they were able to basically take over the entire directory node system of the TOR network, and through that, every new hidden service that was put up during that time, and also accessed during that time, would basically be run in plaintext through their services, and they would log those addresses and then subsequently access them. Now, at Northeastern University, they were actually running analysis on the network, and they had a bunch of honeypots set up, and basically they had a bunch of hidden services on the network, and they noticed that every time they created a new hidden service, or anytime somebody accessed their hidden service, another request was being made to their service, and that was basically us, quote unquote, them connecting to these hidden services and hashing all of their pages to see if they match the deep web hash. And there was a pretty interesting article that they published about this. There were many conferences held, some of which were kind of shut down by the FBI because they were worried that, you know, there was a huge breach in the Tor network, or that like there was an active kind of malicious attack on the network itself. They thought that we were able to in some way exploit the services that we were they were accessing. But yeah, little did they know that we were actually just scanning every single Tor hidden service or most of every Tor hidden service in existence, to try and find the deep web hash. So I mean, we didn't find anything either. So there's that. The other infeasibility of brute forcing the deep web hash is that we're looking for a page, right? And the contents of that page could be basically of any length, of any reasonable length. Like it could be an image, it could be a video. We really don't know what could be on this page, and that basically leads to an unrealistically large number of possibilities as to the different pages that we would have to brute force in order to try every single one. There have, however, been some ideas that the deep web page might actually be referencing a URL. And since then, there have been some community efforts. One community effort that's going on right now to hash various common services such as Pastebin and other kind of an imager and things like that, randomly generated URLs that we can hash actually just the URL of to see if the URL matches the deep web hash. So those are kind of like relatively promising. Obviously, we can't search every single URL, and we can't search every single onion address. That's one of the other commonly suggested ideas, is to search every single onion URL. But there's like basically it would take trillions of years. Let's just put it that way. Even in the most ideal circumstances. So yeah, brute forcing, yes and no. I'll throw it on over to Puck, I think, now, right?
Yeah,
Should
sure.
we should we be looking for the deep web page before solving the LP, or?
Well, let me tell you, Tyler. So basically, there are two main theories about this. About like, should we be looking for deep web page before solving LP? I mean, obviously, it's either before or after.
But which?
So we can either. Well, let me speak now. So we can basically start looking for the page now, or we can start looking for it after LP is solved. The main, I guess, idea about it being after LP is solved is well, they gave us LP, and the hash is kind of like a subsection of that. So it kind of makes sense to finish solving LP and then go into like the hash. And also on, as I stated earlier, the page 56.jpg, which the deep web hash is on, is titled an end, which could basically mean like an end of Liber Primus, like an end of the puzzle. And that kind of implies, you know, it comes last. And the other theory is that we could start looking for the deep web hash, the deep web page now, which basically implies, or not really implies, like if we're gonna start looking for the deep web hash now, we're gonna do that in like while we also try to solve LP. So basically, we just throw efforts at both of them and just hope it works out. And that's the way to like. This is, I guess, the safe option to kind of ensure that it can be either one, that the hash solves LP, or the LP solves the hash, or it could be neither of those. But like this is the way to ensure that we at least have some solution if both of those are possible. And I'll hand it over to Twix to discuss his hash alarm.
Yeah. So with the CicadaSolver community, we have created a browser add-on called Hashala. It's a tool created for the community by the community, and it basically enables people to check automatically if every content that they'll browse on the internet hashes to the deep web hash. So, for instance, let's say that you load a website, and in turn this website shows an image. Well, thanks to this add-on, the image will get hashed and then compared to the deep web hash. In case the hash matches to the deep web hash, you will be prompted with a message asking you to basically share this discovery with other solvers.
All right. So now, I guess you want to talk about hash collisions. Twix, you want to
Yeah,
start
sure.
on that?
First of all, as Puck said, hash collisions, hash functions are basically one-way transformations that from an input generate a fixed length output. So in the case of this deep web hash, it is 212 bits output. However, because we can pass in any input of any length, they must exist hash collisions. That is to say, two messages completely different, but that will produce the same hash. And well, in a theoretical world where we could find all collisions for a given function that hashes to the deep web hash, well, how could we tell which one is the one that Cicada 33.1 intended for us to find? For instance, one can say that the message should be PGP signed, so that is to say with the common algorithm that Cicada uses. However, like if the message would be PGP signed, why in the first place use an hashing algorithm? It is quite difficult to answer that question. However, thankfully, this question is only a theoretical one because, well, currently we don't have a single collisions, and we will probably won't find upon thousands of them in the future. And I talk about the multiple hash functions. And well, basically there exist many different hash functions. These functions have different names and different properties, and currently we don't exactly know the exact hashing algorithm that was used by Cicada 34.1 to create the deep web hash. Does anybody want to talk about the case of the hashing algorithms Blake 2B and Blake 212?
I mean, I feel like you're the driving authority on all the different hashing algorithms.
Okay.
I'll big you up a little bit because maybe Twix is the guy. I noticed you said earlier, by the way, that your plugin was made by the community, but I feel like it should be put out there that it was made by exclusively you.
No. And Crash Demons, I have to say.
Oh, Crash Demons helped you out as well. Yeah, but you really pioneered the idea of it was kind of floated. I think it was by me where I was like, I'm just going to go on what was basically Wikipedia and just find out what all of the 512-bit algorithms were. And I did a little bit more research and like looked around for all the possible algorithms I could find. And I just like made a list of them. And then I kind of said, right, I'm gonna try and find a hashing algorithm, like a working algorithm for each of these methods, and try and get them all like together into one library. And then I think I did like a couple of them, and I think I got like one or two of them working, and then I abandoned the project. And then like a couple of days later, you were like, oh, by the way, I finished it. And I was like, what? That was crazy.
Yeah, it's absolutely amazing.
Yeah. So to give like a little bit more of a background on what it is that you did and why you went to all that effort. Basically, a 512-bit hash kind of implies the most common hashing algorithm for a 512-bit output, which is SHA-512, but not necessarily. Especially with algorithms named things like Blake 2B and Blake 512, where there's like loads of references to William Blake in the 3301 in the Cicada puzzles. Basically, the idea is we don't know which algorithm to use on the page to necessarily determine whether or not it matches the deep web hash. They never tell us which algorithm they're using. So one of the things that Twix did is made it really easy to hash any file page into pretty much all of the different using all the different algorithms, and then comparing them all to the deep web hash to see whether or not they are a match. And this is also implemented in your in your browser extension, I think, as well, right?
Yeah.
Yeah, which is crazy. So it runs like in the browser. It does all of them in the browser. That's nuts. All without slowing down your internet traffic at all.
Well, it tries to. Well, yeah.
Unnoticeable. Yeah.
Now, one more hypothetical possibility is that the hashing algorithm that is intended to be used is actually a bespoke, custom hashing algorithm that is intended to be revealed to us through the LP.
Oh God, I hope not.
I swear to God, if they make their own hash, I'm gonna.
How are we supposed to?
Cicada.
Oh my God, that's like finding two needles in like a number of haystacks. Like it's like finding two needles in two haystacks made out of needles, and you like they have to be specific ones.
No, it's that you have to make a haystack out of needles.
First construct your own haystack and then find a needle inside of it.
Well, no, then you know where it is.
It's like they invented
make your own haystack out of haystacks, and then find which needle.
Oh my God, this is going nowhere. The
point is, the progress on the puzzle.
we would need to both figure out their hashing algorithm and also then subsequently hash basically every page in existence. Which
is an absolutely monumental task.
Okay.
Yes.
Okay, actual haystack analogy. Imagine finding a haystack in a needle. That's what it's like.
That doesn't help anybody.
Okay, think about it. That's right, you can't.
I refuse.
Exactly.
Moving on.
It's too complicated to think about. It's precisely it.
Yeah, I mean, they could have made a custom algorithm. Not entirely their style. They like using their own kind of like combinations of stuff. But I feel like for the encryption thus far, they've used like and as you should use off-the-shelf kind of encryption. Because if you make your own encryption, you'll end up with security flaws. That's just the rule of thumb.
So now that we've discussed a little bit as to how we might be able to find the deep web hash, let's talk about what the deep web hash might be. There are a few possibilities. Some of the popular ones are that it might be a new Liber Primus page, that it could be used to verify the Liber Primus' solution, or that it's the source code for a web page. The deep web hash could also be a URL.
Yeah, I would like to jump in and talk about that deep web hash could be used to verify the LP solution. I kind of touched on this before where I said like the hash might solve LP or the LP might solve the hash. Basically, this is the theory that the hash will solve. Um, actually, it's kind of like between both a little bit. So basically, if the deep web hash is to verify the LP solution, it's basically just like it just confirms LP being solved. So basically, if uh, the LP is solved and well, first off, it could lead to a page on the deep web, and we just hash that, and then, and if that's it, then okay, easy. Or it could basically be like a whole new, it could lead to a whole new page, or basically, what I mean by page, I mean like an actual another page in Liber Primus, and that could be, we could like hash that and get the LP solution that way, or that's not necessarily LP solution, but the next step. And that could be what the hash is to, what the thing hashes to. Or it could be the actual like LP solution, so like all the words and what everything says. This is like the main theory of this.
Yeah.
That and that's the page which is all of LP pages that, and it's within the deep web that hash to the deep web hash. That's like, I guess, the main way of thinking that the deep web hash is to verify the LP solution. And I think that's pretty much like undisputed in that regard, that if the LP or if the deep web hash is to verify the LP solution, it'll probably be through that.
Yeah. I've always been of the assumption that, because one of my main questions is why give a hash, right? Where they could give a signature or like pretty much anything. Why give a hash? And I feel like it's kind of a mixture of the two, because the solution, like, let's say we decrypt like one of the pages of the LP, and it kind of gives us or at least like the whole LP could give us a pointer towards a key that we're supposed to find, but we're never going to know exactly which key it is we're supposed to find until we verify that it matches a hash. So, I feel like LP could be pointing us towards the page in a broad sense, and we're supposed to just kind of brute force like the last mile type situation.
Yeah, you can see
That I
that.
think is a fair interpretation. That's just my just one of my
Yeah,
theories.
I think one of the things about like this whole deep web hash thing is that it's so open, and that like there's no real, this is, I guess, kind of a meta thing. No Facebook. Basically, just like the theories are so like they can basically be anything. You know what I mean? As long as they have like any sense of legitimacy, and because like there's nothing to figure out. We'll touch on this idea a little bit next episode, but like it's just there are so many theories, and if you ever like join the community or looking into this stuff, be prepared for that, because there is no way to prove anything unless we find it. And I
Yeah.
mean, if you find that, then there's probably gonna be millions of people joining. So
I
Now,
kind of love how
building
there's such a definite end, that there must be something that hashes to that hash, right? I feel like
yeah,
that's one of the biggest arguments against people who say that the LP is like a throw off, like there is no solution and we'll never solve it. I mean, they could have just generated a random string, but like that hash pretty much has to hash to something, right?
and it does. Hashes do a lot of things. If you go
Well,
back to hash
yeah.
collisions.
There's a theoretical infinite number of hash collisions, but let's not even talk about it. Yeah, I think that's one of the cool things about it is you can create something like the browser extension, which genuinely it has like a trigger that it's like you solved the deep web hash. You can actually definitively prove that it's the correct page. Um, which again really kind of teaches people the concept of verifying hashes. on a very basic level. Um,
And perhaps that was even part of 3301's motivation for including the deep web hash. There is the popular hypothesis that we are not even meant to find it, as the wording of page 56 merely says seek.
Yeah, they say
Yeah,
seek.
and all right, before you go, oh, seek means find. Look it up on Google. It says attempt to find. I've already had
Attempt
that
to
argument
find.
before.
That's maybe it's
It's
just
kind
supposed
of
to be
like,
about the friends we make along the way.
all right, before we get into memes, let's talk about an actual meme here. I threw this idea out as a total meme, and then I started thinking about it, and then it's like, well,
Mhm.
maybe it's just one of their stupid pranks that's like, seek yourself or something. Like,
Hmm.
it's like tunnel within, and you will arrive within Instar. I cannot remember the line, but you know what I mean.
Hmm.
It's like, I mean, it kind of just gets you thinking. Probably not, but it's fun to think about. And also, uh, there is, I guess, just a general hash possibility is that this kind of goes with what Tyler was saying a little bit earlier. 331 basically identified the page or the deep web page with a hashing algorithm instead of PGP signing it because the page is hidden in plain sight, and
Mm.
that like we're making things more complicated than it is,
Mm.
and it's
I was thinking
basically just like
that they could have
they
just
can't PGP sign
supplied
it because it's over there, you know.
a separated hash. A separated signature. Like in PGP, you can create a signature which like wraps the text that it is signing, but you can also just sign an arbitrary file and provide a signature file, which probably wouldn't have been clean enough to post on just the page. And also they haven't ever used one of those before. I suppose it's kind of the same
They
thing.
also haven't used a hash before, so or one of these crazy deep web hashes you gotta find.
Yeah. It just makes you wonder why they've decided to kind of do it in this way, especially to go as far as not even to specify the algorithm used, because
I think, to be honest with you, one of the main theories about the hash is that it's a Blake hash. Either like Blake. I mean, you like, and I feel like it basically the hashing algorithm is going to be probably hidden in plain sight if you're going to go along with this theory right here. And I think everything is just like if it's just something that we're missing, everything is just going to feel obvious once we find it. Maybe that's hindsight bias, but like I feel like this theory of things being hidden in plain sight, it's going to be everything hidden in plain sight. You know what I mean?
yeah, if just because it's hidden in plain sight doesn't mean it's easy to find. There's a lot of stuff
No,
hidden
no,
in plain
no,
sight.
not at all. If I implied that, I do not mean to, other because it's been 7 years. That does not really work out. I mean, I wish it was.
Yeah.
Hidden in plain sight, as in like it could be a past step that we're just never hashed or something, which probably isn't the case, but something along those lines, you know.
Mm. Yeah. There is the other question of why literally just finding a page they thought that would be a good puzzle step. Like it's a lot easier and it's easier, quote unquote, and less involved, quote unquote, than like their other puzzle steps where it's like, decode this message or like, here's some crazy cryptography or math or whatever. This one's literally just like, oh, see if you can find a page. It's kind of like it's like there's a name for it, but just like a lost errand, basically. Just like just search every website in existence and see if it matches this. They're not really I guess other
It's
than
simple in
exactly
concept.
how we're going to go about that. The actual act of searching every page is fairly simple in in its actual like how you search a page. It's
Yeah.
just that we have to get creative in which pages we search, and they really gave us like no indication of
Yeah, it's just a
exactly
page
where
of
we should be
deep web.
looking. I would have appreciated like more of a of an indication as to where we're supposed to look, other than the deep web, which is
331
literally
being cryptic
like,
again.
most of the internet. Like everyone's seen all of those iceberg charts, where it's
Oh, I
like
was hoping we wouldn't have to talk about the icebergs.
the deep web is like 99% of the internet. But it's kind of true.
Yeah, it is. The iceberg is the
It could just be someone's
cliche.
like home Raspberry Pi server. Like we have to go to their house. It doesn't even necessarily have to be on the internet. Does it even say on the internet? Just says
On the deep web.
on the deep web. But the deep web doesn't even necessarily reference the internet itself. Could be a closed shell network. We could have to go there. I don't think I've ever considered that before. There you go. Brand new idea live on the podcast.
That's pretty stupid.
Maybe it's on like a Starbucks Wi-Fi. We have to go. I'm not indicating anybody go or mess around with any Starbucks
Alright, can you
networks.
stop talking before you start saying really stupid theories? Just talk about legitimate theories
I'm
here.
kidding.
Okay,
Go to
okay,
Starbucks. It's at Starbucks. It's at Starbucks.
okay. Alright, let me go right over to my local Starbucks and try to solve the deep web hash.
This
I mean,
episode was
Secret, my
sponsored
bad.
by
Secret, my bad.
Starbucks. It actually wasn't. That was a joke. I don't know how
Are you
legally.
serious, dude? Are we sponsored? Are we sponsored?
Oh, dude, yeah. I've been drinking Starbucks all day. Have you not got any? They
No, you haven't given it to me yet.
they
Alright,
just keep
anyways.
sending them to
So,
me.
kind of
Okay,
what you were talking about earlier. I'm not even sure what you were talking about because I kind of just forgot because I've been thinking about Starbucks.
We were talking about
like
why
301
they
made
made
the
it
deep
so
web hash
easy to solve,
easy.
really. Yeah.
They made
Well, there's always
some
the
of that-
possibility. There's always the possibility that some aspect of the search for the deep web hash itself will hold some sort of key or something that will further progress on the rest of LP.
So are you saying the hash will solve LP? Basically.
Not solve.
That sounds like such a damning quote.
No, I don't mean that at all. Like, my mind is not thinking straight right now.
I like where it's like so are you trying to say that to solve the hash is to solve the LP? Is that
I'm gonna
that confirmed?
coerce you into saying hash solves LP.
So if we break down what 3301 said about the hash itself, we see that in their words, it is every pilgrim's duty to seek out this webpage. They don't give us a definite. They don't tell us for sure that it will lead to progress or that it will do anything. All we are told is that the journey itself is what's important.
Yeah, they don't even say like, they don't even reference what's on there or like anything. They just say it's our duty to seek it.
And that goes back to the seek not find.
Are we even pilgrims? That's what I want to know. Like, I mean seriously, like, have we been referred to as pilgrims in the past?
Yes.
Or was that just like a koan
No.
thing? Now,
I mean,
Welcome, pilgrim, to the journey towards the end of all things.
yep.
but is that us?
Beginning of LP.
Or was in the LP? I'm thinking that a pilgrim might be like a cicada, like might be a 3301 member, right? And LP might be an internal booklet.
Then why are they giving it to the whole world?
I don't know.
We're meant to solve it because their members are too stupid.
Well, I mean, they're trying to introduce us, I suppose. So I guess in that respect, we are
The
a pilgrim.
initiation. Solve this book.
Well, yeah.
They did say their members prove themselves.
Yeah.
Yeah. There's a
But
bigger
they
way to
did call
do it.
them members, and they didn't mention pilgrims in the leaked email. Could there be some historical reference to pilgrims, like the?
Alright, okay. This is a little too esoteric for me. Basically, so on that theory that the 331 made The 3301. That 3301 made the deep web hash easy to solve, but gave us a broad goal of trying to find the page in the deep web.
Mm.
I think that's like, or when they say made the deep web hash easy to solve, it's like easy in concept. I think that it's like, personally, I think it's that this is to keep people solving LP because they knew, like, if you give just the LP, people are gonna get like, they're going to be more likely to just get burned out from it and be like, oh, this is impossible. But if
Yeah.
you say the hash and you label it as an end, and its hashes are used for like
It's like a
verifying
side
stuff for the
puzzle.
same, it's kind of like, it kind of gets you thinking like, oh, okay, in order to do the hash, I need to do LP.
Page.
And that
Yeah.
kind of keeps you going LP into it. It keeps you
Yeah.
thinking about LP. And they want LP to be solved, and the hash is just a
Yeah.
either something to just keep us going on it, or it's an actual another step of the puzzle, or it's something we haven't even thought of. I mean, who knows? We don't have it yet. It's a page
I
within the
mean,
deep
yeah,
web.
and now you see why it's been like 7 years.
Yeah, I mean, we
Almost
don't know
8.
anything. And more on that will actually come next episode, episode 3 of the CicadaCast, where we're gonna talk about, not to get ahead of ourselves, but we're gonna talk
Ooh.
about like that idea of like we know nothing.
Spoilers.
Yeah, see, I'm spoiling
Yeah.
something everybody
Tune in
knows.
next week where we talk about how little we know.
Yeah,
And speaking
the problems
of
that
knowing
causes.
nothing, speaking of knowing nothing, as we all know, in 2012 and 2013, the stated aim of the Cicada 3301 challenges was recruitment. Unlike 2012 and 2013, the 2014 stated intent of the puzzle is enlightenment. And I suppose, what do you call somebody who is on a journey towards enlightenment? That would make us pilgrims if we choose to continue trying to decrypt the LP.
Yeah, maybe we are pilgrims after all.
You've gone through a whole circle of what are we?
I mean, what else do we have to work with on the deep web hash?
True.
Oh,
Might as well
we've
just end the podcast here, you know?
honestly, it's about that time. Oh, I
About
was
that
gonna
time.
reference. Do we want to say? This is totally out of left field. I have not. We've not talked about this, but we could kind of mention whether or not it has anything to do with Bitcoin. I think a lot of people bring up Bitcoin. There's a lot of confusion around like Bitcoin using SHA-256, and the deep web hash being 512 bits, which which is a relation to some people. I don't know.
No.
I guess like the short answer is no. I mean,
yeah, sorry to disappoint you, but no, 331 is not Bitcoin.
Yeah. No. It would be nice though if it was just like a big tasty Bitcoin wallet. If it has been looked
CicadaCoin
into,
really coming in.
no, I'm not going to mention that. That's for a very distant future podcast.
And we're just gonna leave it at that. Y'all can start thinking about CicadaCoin if y'all want.
I will. Don't tempt me.
I mean, no, I'm kidding. Is that basically all we have for this discussion here? I'd say it was
Pretty much.
pretty good.
Yeah, we can leave it here.
All right,
Twix,
cool.
you have any hot takes?
No, I think that we gave a pretty good overview of the deep web hash and well, basically the secondary part of the puzzle. So to solve Liber Primus, we could either decrypt the runes or solve the deep web hash, and yeah, I think we did quite a good introduction to the deep web hash. Well, and also thanks for inviting me, I guess.
Oh, thank
worries,
you for
Twix.
coming on. I was
You're
about to say
welcome.
that. Like,
guy
you've
is
done
a
so much work on the
genius.
deep web hash. You are the go-to guy on this.
Yeah.
And also thank you to Artorius and Tylo for coming onto this again. This has been CicadaCast episode 2. Thanks to everybody for coming live or listening later, and have a good night.